Oh no!
Testing, 1, 2, 3.
Oh, yeah, okay.
Okay. All right. Ladies and gentlemen, let's get to it. Welcome to another lecture of EECS 298, 3D Interactive Technical Art and Animation. Okay. And I got something I want to show you. And so I'm going to take a tiny bit of time to show you what I've been up to, because I imagine some of you are curious about this. If you go to EECS298.com, for the longest time, people would go there because I'd have cool new gameplay or features to show them. And they say, oh, Austin, that's cool, but I'm on my phone. I'm on my phone, so I can't play the game. Well, I have some new touch controls in the game, and I want to get a feel for whether they're any good or not. So if you go to EECS298.com on a mobile device, which you don't have to do right now, okay? This is, I don't want to waste too much of your time. But you can see down here, I'm jumping around on my mobile device, and you can see me. It's pretty accurate, I think. You do get used to it. It might be a bit slippery. Some people were telling me that different phones like had slightly more or less slipperiness. I have no idea what's happening there. But if you can get up this tree on your mobile device, I think that I've accomplished my objective, because this tree is hard enough on computer, let alone crappy mobile controls. So anyway, you can use the top part of the screen to adjust your camera, and you can tap on the bottom right to jump, and left is your virtual joystick, okay? So in any case, yeah, if you have any feedback on any of this stuff, please let me know. We've got new characters coming extremely soon. Like, we've got footage of them running, and we just have to integrate them into the character select. And that's it, okay? Well, you can also continue now. So if you end up running out of lives, you don't have to refresh the page. You can just click the retry button, which I think has like some Persona vibes. I'm kind of pretty happy with how that turned out. But anyway, let me know about all this stuff. And now you have no excuse for not testing out my newest features when you're on the bus, okay? Anyway, thank you for the feedback, and there you go. By the way, yes, I've got some other stuff. Evan and I have been working on homeworks. Got some of that to show you. If you're curious about the structure of the course, this is just one big ad for EECS 298. We start by teaching you Blender basics, right? We then move on to teaching you armatures and cool stuff like that. You can actually pose characters, create bones, rigs, bind them to skeletons, create really cool stuff in-game. We then move on to animation. Does anyone know what this character is? I probably can't help you learn to animate this well, but you'll do a lot of animations, okay? We have a fun break week, okay? Has anyone ever wanted to do 3D printing, but you just never found time to do so? Well, I'm going to give you college credit to learn to 3D print stuff, okay? So you should take the course if you can. You can audit the course if you want to, okay? If you're graduating. So this is like our break week in the middle of the semester, where we're going to teach you how to get 3D things from real life into our digital worlds, right? Photogrammetry, scanning, right? But also the other direction. How do we get digital things from the digital world to the real world, right? Which is the opposite. These two things are opposites, and so this homework is just called 3D IRL, okay? I actually should literally call it that, 3D IRL. Anyway, so let me know if you have any feedback on any of this, because I really, really appreciate it, okay? And by the way, if you want to take this course, or it sounds cool, or you know someone who might like it, yeah, please tell them, all right? Advertising is my biggest problem. I'm not built to market, okay? So I need as much help as I can possibly get. Otherwise, 5 people are going to take the course, and then it gets canceled, and then we're toast as far as 3D on campus goes. Okay, so let's not have that. That would be the bad ending for sure. So I appreciate any help. Thank you. Okay, ladies and gentlemen, we are in the middle of Project 2, and I've got some homework 6. I just spent like 4 or 5 hours standing up here and doing 440 lecture and 494. It's all packed on my Mondays and Wednesdays, so sorry. We're in the middle of homework 6, and I've got some very good news for you. We got someone, I'm not going to say who, okay? They might not even be in this room. We got someone who's tearing through this homework like it's nothing, okay? Which to me says that the off by 1 pixel fixes that we did, the similarity score, it's really making the assignment much easier than it was last year, which means, personally, I'm thinking in my head, this might actually be a 1-week homework that I accidentally gave 2 weeks to. And everyone in the back is like, don't make a change, don't change it. Okay, if I make a change or if I make it harder, it's going to come next year, okay? I'm not going to make your lives harder just because you got unlucky, okay? Anyway, this is not to say that you should wait a week to start it. You should definitely get started, okay? Because it is still, a stiff challenge, and the final suite really is going to be very hard, okay? But the final suite is only like, I think, 10 to 20% of the assignment credit. So even if you just skip that part completely, you're still getting a pretty good grade, like an A- or something on the homework overall. So it's looking good for you, okay? If you're tired, if you're really needing a break, it might already be here. Who knows? So, yeah, let me know how that assignment is going, and hopefully that is good news to all of you. And then you can get to the really cool assignments. Like I think you're going to love. Homework 7, Homework 8 are going to be sick. Homework 9 hopefully will also be sick. It's going to be about implementing a particle system. And everything I hear, I've never done it myself. I'm going to do it over spring break and create the assignment over spring break. Everything I hear about creating your own particle system is that everyone gets addicted to it because it's so fun and so cool and the results are beautiful and it's not actually that hard. So that sounds pretty good to me. Hopefully that's how the homework 9 will turn out. We'll see. Anyway, be sure you get started early on homework 6. Otherwise, you can make this assignment very hard by starting too late. Okay? All right. So we got an engine for you today. This is an engine that is near and dear to the hearts of many. This is RenPy, or RenP. This is an engine that is dedicated to the visual novel genre. Okay? The graphic novel genre. This is a fan favorite and also one of the primary weapons in the arsenal of our local beloved Nochi Studios, run by Professor Natalie Fang, who teaches the, who teaches the SI 311 course, the Games and UX course. If you want to meet her and learn from her, you can take that course. It's a great idea. So they use their RenPy and engine to make visual novel games really quickly and really effectively. You get a ton of features like a automatic save and load system when you use RenPy. You don't have to implement that yourself. You just get it. Okay. It supports variables. It supports this branching decision trees. You can even do interactive rendering and interactive gameplay if you want to. I have worked a bit in RenPy. It makes those things very awkward. But you can, if you want to, build your own unique battle system. You can make a platformer game in RenPy if you want to. It's just a bit unpleasant, okay? But it is expressive enough to do that. It is most famous for the game Doki Doki Literature Club, which is a really very wholesome game about... Why are you laughing? It's a wholesome game about a group of schoolgirls who meet to discuss literature. And so you should definitely play the game. Okay, it's really a okay. Yeah. Don't worry about it. Just play it. Okay. Okay. I've never played it. It's too scary. Anyway, but it gives you, if you know what this game is about, then you know that RenPy is a very customizable and very flexible engine under the hood. Despite how rigid it is and the things it gives you, you can go in and really customize a lot of that stuff. Yes?
The stories that the dev has put out about the making of Doki Doki Literature Club and how much he had to just break the engine, they were fascinating. If you look it up.
Yeah. Oh, I haven't looked it up. I'll have to take a look. But the important part there is that it was possible, right? Yeah, it was possible to really break this engine in half to get a really unique experience going on. But, the most easy thing, like RPG Maker, it's going to fight you a bit if you want to make anything that doesn't fit into its understanding of what a visual novel is, okay? So be careful, all right? There's a surprisingly strong market for these kinds of games. Have you ever heard of a game called Long Live the Queen? Have you not heard of this game? Okay, well, take a look at this. On Steam, only about 6,000 reviews, okay? This is probably $1 million, okay, in revenue. Now, take home is way less than that, but there is a market. It's not a super popular market or super well-known market, but there's a nice, strong, healthy niche for this kind of game. Yes?
Long Live the Queen is stupid hard. I've never beaten it. I keep dying.
Really?
Yes.
It's good replayability. Okay. Is it a roguelike?
Kind of.
Okay, gotcha. All right. So the engine itself is open source. It was created in 2004 by Tom Rothummel. I know nothing about this person. There's a website you can visit if you want to. Heavy use of Python as a scripting language. You might have guessed that from the name. Plugins are available for Unity. So there are teams out there that use RenPy for their visual novel dialogue engine in action games. So the main action part of the gameplay is written in Unity, and then it calls into RenPy to do the dialogue and cutscenes and stuff like that. So pretty cool. It provides a strong suite of common features out of the box. And I'm not actually going to show you the demo project on my laptop, but you can download it and mess around with it if you want to. Okay. All right. So some fun stuff. Kojima experiments with a new camera system for Metal Gear Solid on the PlayStation 1. This is super cool footage. If you know anything about Metal Gear Solid 1, it is a game that has a very unique, for its time, camera system. It's extremely cinematic, one of the early 3D games on console. And you can see them trying to figure out how this game is going to work with its camera. And the way they did it is just incredible. Okay, watch this footage. It's not long, but watch it. Okay. So they've created a Lego set, okay? And they are kind of demonstrating how the camera should work, right? It has this top-down view, but then when you go against a wall, it kind of lowers and it looks at things, right? And it gives you this really interesting view around corners and stuff like that, okay? And you can see what the final game ended up looking like and what camera angles they chose down here in this bottom left footage, okay? And so you see when you were doing anything new, and this kind of approach to camera management was very new at the time, paper prototyping is what this is called. Very important in game design. It is how you try and experiment with new ideas for mechanics and technologies without dropping the big bucks to actually implement them. These days, implementing a camera system like this in Unity, super fast. It's not very expensive. You might as well just do your prototype in Unity so you can keep the code if you end up really liking it. But back in this day, you're programming on the PlayStation. The libraries are not very good, okay? Your engine might not even be ready yet. And yet the game designers have to start building content, right? And figuring out what the story will be and how things will work. So in that era, a lot more of this was super important, okay? And it's super cool to see this. It's very humbling, right? These big multi-billion-dollar game franchises and legendary creators playing with Legos. Okay, yeah, that's how it always starts. Okay, how is your code hygiene feeling? Any ideas? You've got your code bases, some kind of spicy, some very clean. Okay, how you feeling, Jose?
Based on all the comments I'm hearing from you about how some code bases are and how other people are cleaning it, I'm like, mine is probably on the lower end of the spectrum in terms of cleanliness.
Clarity?
It's pretty good.
Yeah.
Some of it makes sense, some of it doesn't.
How dry is your code base, would you say?
Better than my 494 stuff.
That's good.
Worse than how it's still worse than
Good.
Because of how layered it is, there's a whole bunch of like dead functions. Just
dead functions.
Ooh.
Yeah, you want to get rid of that if you can. Remember, you don't need to keep it around in a comment in case you need it later. You've got version control. You can always get back to it. Just delete it, right? Anyone else? Code-based stories. Code-based. Yes?
I had like 40 member variables in one of my classes, and I just threw them all into a couple structs, and now I have like 20 member variables with a few structs that have another 20 members.
Okay.
But it's more neat, so it's okay.
Yeah. I'm like, I can't decide if I like that more or not. Yes?
I'd say the main thing is that my name just looks like a bunch of if config has this value, read it in, else do something, and it's just 100 lines of reading stuff from the config files.
My the staff solution main function is like, I think 4 lines long. And I know I overheard someone saying that like their entire code base was still in their main function. Like one file, everything is in the main function, and you're just rocking.
Respect.
Yeah, respect. Yeah, you chose professional difficulty mode. Okay, so one really important question is this notion of what is a clean, good code base is a very ephemeral one. It's a very nebulous one. It's hard to pin down. And that's not you being making a mistake, right? That's just how it is. There are lots of different philosophies on what is good code or not, and it changes dev team by dev team. But one thing that's fairly universal is the concept of dry, which I think we've already talked about. You may have already heard about it in other courses, but DRY stands for don't repeat yourself. If you ever find yourself copying and pasting code, you are almost certainly violating DRY. The idea of DRY is that for any piece of data, you always want there to be one true authoritative source for it. Okay? This kind of gets back to, you've got a bunch of actors and you want to make a new data structure to hold them in a different order. Are you making a copy of those actors or are you referencing those actors? The references still means you just have one actor. That is the authoritative source for the state of that actor. But if you're making copies, you are in big trouble. Okay? Now you might have multiple actors that are supposed to represent the same actor, but they're actually different objects, they're copies of each other, and they have different data. They're not synchronized anymore, and you're in big trouble. Another really, really big thing, it's harder to pin down even more, but if you ever find yourself adding something to your code base, you can get a good feel for the overall quality of your code base by asking yourself, how easy was that to add? How hard is that to add? How many different places in my code base do I need to go and find and fix up if I want to add a new enemy type or a new collider type in homework 6? If I need to jump around to 7 different places in my code base to fix a bunch of stuff up, I've got all these maintenance sites everywhere. You're going to forget them. You're going to introduce bugs like that. If, on the other hand, it's super easy, it's like I go into my code base in one place and I just add like 1 or 2 lines of code, and now I have a new enemy type that does some pretty cool new things. That's a crazy good code base, okay? Your code base quality determines how easy it is to expand that code base and add new things. As that gets longer and more burdensome and a nastier process, that is your code base degrading in real time in front of your eyes, okay? If you can feel that and work backward to find out, wait, why did this get so nasty to add an enemy? Then you can fix up your issues and you can solve your problem and keep your code base very nice, okay? So that's another way to think about this. All right, and I bring this up because recently when I made the switch from pixel perfect to similarity scores, I thought this was going to be a huge effort. It took me like 35 minutes, and it was working. And it was working good, and it's still working, like days later, and a lot of grades later. And I'm like, dang, maybe my code base for the autograder is better than I thought it was, at least in that area that I had to work with. So so keep that in mind, all right? Code base quality is a very nebulous topic. It's going to differ team by team. But there are a couple things that are just always going to be there. How easy is it to add things? And how easy is it to accidentally make a copy-paste issue, right? And that's going to help you out, all right? Okay, anyway, blah, 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 blah. Okay, with engine dependencies, okay, you're introducing more and more things to your code base. A week and a half from now, you'll introduce a Lua. Are you allowed to sell a game that uses Lua? You integrate that Lua code base, you integrate SDL into your code base. Can you sell that game?
Well, I'm pretty sure Bolacco was moving to Lua, so I can sell stuff.
So you have a strong notion that it might be possible to sell, but you don't know if the Bolacco dev is about to get sued.
I have no idea, but my guess for something like STL is it's open source, so you can use it.
Open source does not mean you can use it. Unreal Engine is open source. Well, you better pony up if you want to use that, right? You're going to have to pay license fees, right, when you make royalties, right? So open source just means the source is open and you can kind of view it, right? At least I think that's what it tends to mean. Public domain is when this is like, you can do anything with this, right? Usually open source projects come with a license. And have you ever gone to a GitHub repo like this and you'd seen this license.txt? Do you ever see that? And you're like, huh, and then you ignore it, right? Of course. If you look in this, you'll have some information, okay? So look at this right here. This is the zlib license. And here's the entire license. What does it actually say? Well, it was written here, at least put here, by Sam Lentinga, okay, the creator of SDL. The software is provided as is without any express or implied warranty, okay? So in no event will the authors be held liable for any damages arising from the use of this software. This says you're never allowed to sue us, okay? That's what this paragraph says. Permission is granted to anyone to use the software for any purpose, including commercial applications, and to alter it and redistribute it freely, subject to the following restrictions. So here's what you need to do. The origin of the software must not be misrepresented. You must not claim that you wrote the original software. If you use the software in a product, an acknowledgement in the product documentation would be appreciated, but it's not required. Okay? You don't even need to tell someone that you're using SDL. Okay? But you can't say that you wrote it, okay? And altered source versions must be plainly marked as such and must not be misrepresented as being the original software. So if you take this code and mess with it, you can't claim that I wrote it because you wrote it, right? This notice may not be removed or altered from any source distribution. So if you bring down the source code for SDL, you have to keep this in there. You can't delete it, okay? That's it. That's it. That's pretty nice, isn't it? Is this public domain?
No.
No. But it's pretty close. Yeah, it's pretty close.
So it says that you need like the license in the, or when you pull it down, right?
Yeah, in a source distribution.
So like,
yeah.
When we, like for our engine, where would we put the license?
We would have to put this license
You're not
somewhere in our code
well,
base if we give it to other people.
Yeah, you're not pulling down the code base. You're pulling down the libraries, the compiled forms. So I don't think you'd need to do it in this case. If you are like selling a modified version of SDL, which is a code base, you're selling a changed, fixed up code base to some company, you need to make sure you don't delete this. Okay? I think that's what it's saying. But I'm not a lawyer, and you should know that. This is not legal advice. Okay. All right, so another question, Unity's third parties, how do you find them? I showed you the other day, you can go to software licenses under help, and you can, there's a copy right here. And if you recall, SDL is in there, okay? They're using SDL. It's unclear what they're using it for. SDL's zlib license doesn't mean a lot for us. We can use it. It's a very permissive license. So is MIT. I want to show you, let's GitHub. Okay, I want to show you another license, okay? If I can find it. Is there a license doc.txt in here? Where is it?
You can get it from the sidebar.
Oh, here it is. Here it is. It's GPL3, okay? If you see the GPL license, you usually have to run for the hills, okay? Anyway, some open source advocates might not be happy with me for saying that. But the GPL license is a very famous license. It tends to be associated with many open source projects, not SDL, but many that are associated with Linux and GNU and that kind of stuff, okay? So what is this GNU license, okay? What is this GPL license? Well, I think it's very long, and I'm not actually going to read it. But what I'm going to tell you is that, hey, it's free for you to use. But if you ever make any tweaks to it or changes, you have to publish all of your changes and all of your code. That includes the code you wrote from scratch that it links against. So I'll give you an example. What operating system does the PlayStation 4 use? It's not Windows. Yeah.
Isn't it a Unix derivative?
Yes, it's known as a BSD. Okay, stands for Berkeley Software Distribution. I think it's a Unix derivative that was developed at Cal Berkeley. And it is a rival of Linux. Why didn't they choose Linux? Linux is the popular one. It's probably become more stable, a bit faster maybe. It is better supported and better known.
The whole thing is that because of this GPL license, if you ever use software that involves the GPL license, you are then forced to make your own thing open source if you use this library.
That's right. That's right.
So it forces you to make it free and open source.
Yes.
And if you don't want to make your thing free and open source, this is an issue.
Yeah. I think sometimes you can pay for a non-GPL license, but I think many of these you can't do that for. The GPL license, Sony, a company like Sony, does not like it at all. Because if they go in and make a bunch of tweaks to Linux, as they would probably do, to create their own custom PlayStation operating system, right, with all their proprietary secret sauce, because of the GPL license, they must then take that secret sauce and make it public, open source to the world. And those changes might be things that Xbox might be very interested in, or Sony, or Nintendo, or any hackers might be super interested in, okay, who want to compromise the PlayStation device and steal the signing keys and then distribute games under piracy, okay? And so Sony is very spooked about that. And so can I get Linux without the GPL? And the answer is no, but you can grab BSD, which is different, but super different? I don't really know what the differences are. It seems to me maybe not super different. So Berkeley Software Distribution is released under a much more permissive BSD license, if I recall, that is kind of like zlib license, kind of like MIT license. It's just do whatever you want, commercial. You don't have to publish your secret sauce. It's all good. Just don't sue us, okay? Anyway, so this might come up on the exam. Licenses are a thing that matter to you as you bring in more and more dependencies. As a student project, who's going to come after you? Probably no one, okay? As a business or a research laboratory student, a graduate student, they might, okay? Especially if you catch a lot of attention or start to succeed, okay? So anyway, all right. So what are the topics for quiz number 3? That's kind of important, okay? The last quiz came like a wrecking ball out of nowhere. We didn't tell you what was going to be on it, but maybe the difficulty was a bit surprising. I'll probably tweak and balance the difficulty a bit later. But these quizzes, this one will probably be a little bit easier, but there's still going to be a stiff challenge, okay? So please review these topics at least. Know where to go on the slides to find them quickly, because you only have so much time. What we're going to be covering are SDL topics. So if you are, finishing homework 5 and midway through part 6, I think you're going to be in pretty good shape. Okay. If you you probably want to review the input manager a little bit that we talked about last lecture. We're going to talk today about axis-aligned bounding box collision calculations. Okay. This is one you might want to review for Monday. The 2D transformation matrix is a big one, okay? This doesn't feature very prominently in the course projects or assignments, but it is an important thing to know for interviews and in case you want to make your own engine. It's a bit more efficient, a bit faster in the future. And by the way, if you want to get into 3D and you want to do really serious rendering, like you gotta get this. You gotta get into this, okay? So 2D transformation matrix, you're going to want to study those operations that are on it, that can be done on it. Basically any topic since the previous quiz covered in lecture are kind of fair game, but these are definitely the big ones, okay? So, I wish you luck. I'll be looking through the quiz. Hopefully I won't mess up a question like I did last time. One of the questions on homework quiz 2 just got massacred. One of the correct answers was just the text got messed up. I think Canvas trolled me because their quiz UI is very clunky and very slow. So I feel like maybe something got chopped or something. I should have done a check and I didn't. So I apologize for that. You get your points back. All right. So any questions about any of this stuff or comments? Okay. All right. So let's go ahead and let's rock and roll. Collisions are a big deal, all right? And now that we're moving into the real world, we're moving into continuous worlds, how we detect and deal with collisions is going to become a much more interesting topic. It is going to become a very important topic, right? If you can't collide with things effectively, you can't immerse people, right? And collisions are computationally expensive. Okay, especially when you have a ton of actors who need to all collide with each other. So in a grid world, it is very simple, but in a continuous world, we're going to find that it's a little bit trickier, and we need a new technique to deal with this and deal with this quickly. So a reminder of why grids are nice, okay? The question of can the goose move one tile east, 1 unit east? How to answer this question? Is it a hard question to answer? No. Is there something in that cell? 1, 0. If there is, can't move there if it's blocking. If there isn't, you can go, okay? So this question is answerable with a very small amount of code in O of 1 time. It is in O of 1 time if you keep some accelerating data structures around, for instance, a standard unordered map, okay, of some sort of 2D structure with a hash, all right, ideally a fast hash, and an integer to count kind of how many blocking characters are in the cell, okay? Number of blocking actors at that coordinate. So it also, something to note, is that it takes only O of 1 time to keep this updated. So it's not a big deal. It's very fast, very easy to use. But grids aren't really natural, okay? Very rarely will you find games and simulations or any real life that deals with grids, okay? This is a continuous game being played in the real life. This is a continuous game, okay? This is a continuous game, all right? And so is this. Even though it looks like it's a grid-based game, it is a continuous game that uses a grid for its gameplay, all right? This is a fake grid, okay? So life without grids is a little bit spookier, okay? Because imagine that you don't have your characters at these locations, but you have one at these locations. What's the difference? Well, don't you see? This is not 1, 0 that the bunny is at. This is 0.90. So if we stick with our current algorithm that most of you are using in homework 5 and homework 4 and homework 3, can the goose move 1 unit east? The answer is probably yes. Can it? Question is a bit more awkward now, and if you stick with your previous data structures and approach, the answer is going to be yes, and you're not going to feel good about it. Oh, awful. This looks hideous. Okay? Clearly, there should be some sort of collision here. Visually, art style-wise, if you look at their boots, their feet, like clearly they're stepping on each other. Okay? That's not good. Not good. Okay? 0.90 and 1.00, because they're not the same coordinate. Okay? So technically they're not colliding, and this is like, of course they're colliding. This is ridiculous. Okay? This is, I don't believe you for a second that they're not colliding. Okay? This is garbage. Okay? So let's try again here, right? We need some solution. We need some solution such that we can fairly easily calculate at what point they are colliding. Okay? Now, one thing you can do that's absolutely a classic, and I do this when I'm too lazy to deal with anything else. You can just take the distance between the characters, and you can say if that distance is small enough, we just consider them colliding. If you have one big character like the goose and one smaller character like the bunny, you can be a little bit more sophisticated, okay? You can declare a radius around their feet that is the collision radius, a collider, a circle collider, in 3D a sphere collider. And you can do a quick comparison. By the way, this is what this looks like in Unity, okay? So these two characters both have a circle collider, and you can actually adjust their radius and their position relative to the center of the object. And you get a really pretty good approach, really. You will, by the way, you'll have to implement some of these things on homework 6 to get your collisions going, okay? These circle colliders require a couple things to be defined. They require a radius, right? They also require an offset x and an offset y. Sometimes, if you want to be able to do it like an oval, you might give it a radius x, radius y, okay? But here's what we've got here, and we have these two radius values, and we can add them, all right? We also have this value that represents the distance between them. And if the distance between them is larger than the sum of their radii, then you can say they're not colliding, okay? And they are not colliding. Indeed, in this case, it's really visually obvious, okay? But if you move them closer together, and you can say, well, the distance between them is now clearly less than the sum of their radii, then it is colliding. It's considered colliding. And in your homework 6 logic, in your homework 5 logic and 4 and 3, basically your character would say, I'm not going to move. And if they are NPCs, they would reverse their velocity vector. Okay? And then the next turn, they would try and walk away. Something you will see on homework 6, and it's kind of funny, it looks a little bit glitchy, but the algorithm, it's just how the algorithm works, if you're doing it right. Sometimes characters spawn inside of each other to the point where they can't even get out of each other. So every frame, they will collide with the character they're stuck inside, and they will thus spin every frame like this. Okay? Have a little dance party. If you wonder why, Austin, why did you design an algorithm that we have to follow that does this? It's because it was the simplest algorithm that does some good things. And I could make a super complex collision algorithm, and none of you would be able to do it, and you'd get very angry, and you wouldn't learn that much. Okay? So that's why. Okay, when you see the dancing, just say, okay, Austin's trying to save us from a bunch of frustration. Hopefully it works. Anyway, right, these calculations right here will help you determine whether something's colliding. But in our homework 6, we're not going to use these circle colliders, okay? That'd be a little bit too simple. We could have done it, but a little bit too simple, okay? We're going to be doing box colliders instead, okay? Box colliders are classic. You can find them in almost any engine under the sun. And combined with circle colliders, you can get a lot of mileage out of your collisions, okay? Especially if you're making games that are a little bit more artsy, a little bit more retro, okay? Not super realistic, that's fine, all right? This is a box collider. You can see it in Unity right here. Box colliders are defined by slightly more data. You have an offset, X and Y, but you also have a size in X and in Y. So you can create a rectangular box collider that's a really good fit for characters rendered in this perspective, okay? It's kind of 45-degree angle down, or a platformer perspective that's just purely a side perspective, okay? So box colliders, it's a very, very common collision type. The parameters are 4 in number, offset X, Y, size X, size Y. One question is how to detect collisions. And there's a pretty famous, very kind of simple, once you understand it, algorithm for doing this, okay? It's called AABB. It's the kind of thing that very well might show up on interviews. And if you're making your own collision detection, this works super well. How many of you have played this game? Anyone? At the top of the screen, not the one down here, okay? This one. Would you say the collisions in this game are, like, acceptable? They kind of mess up, right? You wouldn't say, oh, you're not happy with them? Oh, bummer. They're fine for what the game is. It's a boxy game. You got boxy collisions. This is using an implementation of AABB that I wrote like a week after I finished running this course for the first time in the summer. I made this game in like 3 days after I finished the game engine architecture first semester. And I'm not sure why I did. I think I was like, man, we're having enrollment problems. You know what all my courses need? A game at the top of the screen. All right, whatever. Whatever works, right? Anyway, all of the collisions in this game, all of them, use AABB, okay? And it works. You can build a pretty cool game out of that. Yeah.
How do you make a game like that at the top of your website? Is that like JavaScript or what?
Yes. So one cool thing about web technologies, and here we go back to the website. Let's go to 494.com. One cool thing about web technologies is that at any given point, you can always do this. Okay, more tools. Where do I view page source? They hit it, didn't they?
You have to right-click anywhere on the page and then hit inspect.
No, I'm going to hit view page source instead. Okay, you can look through and see exactly how this page works. One of the things you'll find is that there's a canvas hidden in here. Not that one. This one. And it has an ID of platform minigame canvas. So this is looking pretty suspicious, isn't it? And you can see that it sources, we also have a little script right next to it called minigame.js. And if you look in here, you can see the entire source code for the game in one file. Let's go. All right, let's go. So when I say that there's someone in the course that's writing all their code in one file, it was me the whole time. No, the staff solution, as you've already seen, is in many different files. But you can actually see all the source code. You can make a mod of it if you want. You can look at how it works. So it uses a canvas, a very thin one at first, but then it expands as you go down the page. as far as rendering goes, I'm using Easel.js, which isn't very good in my opinion. I don't like it very much. I kind of regret it. And it is also using, for the multiplayer, it's using WebSockets. WebSockets connect your client to a cheap Node.js server that I'm running on Amazon EC2 instance. A Linux box, basically, an Ubuntu box. And it's super cheap. And yeah, the server is super simple. All it does is collect where you are and what state you're in, and it just echoes that to everyone. Every, I think, 10 frames or so. That's it. Yeah. So anyway, there are no shared like bosses. The enemies aren't shared, right? There's nothing persistent between players that we'd have to send a bunch of data through for and synchronize for. So that's how it is. Anyway, so that's how. It's kind of fun. JavaScript is kind of a funky language, though. They're hash set. It's like just doesn't work, in my opinion. Don't know. It's just broken. Anyway, how to detect collisions. AABB. This is axis-aligned bounding boxes. Okay? And this is what we mean by axis-aligned. I really like these slides right here. Axis-aligned, not axis-aligned. Axis-aligned, not axis-aligned. Okay, it's very difficult, or it's more difficult to compare these two boxes and see if they're colliding versus comparing these two to see if they're colliding. If these are axis-aligned, then we can very quickly determine whether or not these boxes are touching each other. Okay? And so, how do you do that? Do you have any notion of how to do this? Have you written any code to do this? Have you ever had a reason to do this? You're just going to use the unity colliders or the distance, the circle colliders are even easier to write. You have? Raise your hand if you have written something like this before. Okay. Interesting. I had an interview question where I had to do this. Okay, so how to compute? Well, you've got two rectangles, let's say. You've got two boxes, and you want to know whether or not they intersect at all. Okay? So one really good way to approach these kinds of problems in general is to separate your axes and only focus on one axis at a time. That will make it much simpler to think about, and it will also get you started, and you can expand that to 2 dimensions very quickly. So consider each axis separately, the x and the y, and then you try and disprove things, okay? So in this case, we are only considering the x and, only the x. We're only considering the x dimension, okay? And you can see that we've basically collapsed this rectangle shape onto the number line, and this one onto the number line. We're only considering the x-axis. Now, visually, it's extraordinarily obvious to us that they are not intersecting, okay? But algorithmically, how could you know? How could you know? If I told you, hey, I'm going to go for a run, and the shortest distance that I'm possibly going to run before I get tired and quit is Pierpont Commons. And the maximum distance I'm going to possibly double to run before I will quit is the music school. You have a notion of how far I can run, right? If you then tell me, well, the lowest amount of running I'll do before I get too tired and quit is to the hospital. I'm going to run up Fuller. And the maximum amount I think I can run is to Michigan Stadium. It's pretty good, pretty healthy, right? If you can do that. You immediately know that there's no competition here. There's no possible way I can defeat you in this run. Okay? How do you know this? Well, it's because your minimum running distance is better than my maximum, right? There is no even possibility of us intersecting here. And thus, we have a start to our algorithm. Yes, question?
I think this is what I tried to do for the first homework.
Yeah.
And then I realized it didn't work fully, so I just went back to the circles and it worked the first try. And I'm like,
yeah, well, it's easy to mess this one up. Yeah. I can't tell you how many people messed this one up on the exam where it appeared. Anyway, the first exam. How many of you have taken a look at the first exam ever? Come on. You need to become professional students. So here's what you do. You go to the syllabus. You can also find the exam assignment on Canvas. You go and find the exam link right here. Where is it? Oh! I'm too into advertising mode. Got my marketer cap on. No, 298 doesn't have any exams. In fact, it's super pleasant, okay? The difficulty level of the course will be probably a little bit under EECS 440, which makes it a good course to slip into any schedule, okay? So you should definitely take it. Okay, let's see here. Where's that exam at? Where'd you put it? Here it is, information and previous exams here. That's a pretty cool link, isn't it? What if you could read the entire exam with answer key from the first year of the course? So you can see my glorious pyramid, which everyone memed me for. The pyramid's not making a comeback. It's going away. So I decided to do matching in a weird way. Not this. Here you go. Where you have to draw between the heavenly UFOs up here and the pyramid of answers. Okay, you have a bunch of questions about the linker and stuff. You've got a bunch of stuff. You got some data-oriented design stuff. You have some Lua code you have to write. You've got a continue screen you have to write in Lua code. You have a race you have to write in Lua code, a race simulation. You have to write some C++ code. You have to show the progression of frames of a game with the game like code and scripts and scene files and even images shown to you. Yeah, hell yeah.
Is there a version posted without the answers on it?
No, you can get rid of them if you want. If you want to take it, you know. What's going to happen this year, one annoying thing about the exam was that you had to read a lot of code, right? There would be a couple pages to give you context, and then you have a final page to write code that fits into that context, right? Requirements, all that stuff. It was annoying because it was all in the same stapled thing, so you had to like flip back, write some code, and then flip back through some pages, and then flip back to your code. We're going to have a separate answer sheet now, an answer packet and the question packet separate. So now you can be writing your answers and flipping through on another page and looking at stuff, and you're still writing your answer. You're still there. Create the ultimate exam. The ultimate exam experience. I can't wait. All right, I already have the second exam going, and I'm writing new questions right now. Okay, so how to compute, okay? So like that example right here, you know intuitively that if my maximum running distance is smaller than your minimum distance, there's no way our ending point could ever intersect, okay? You're always going to be beyond me. And so that is the intuition here, okay? You look at one box and you say, hey, if one box's maximum value on that axis is smaller than the minimum value of another axis, it isn't possible for them to conflict on that axis. And by the way, if you can't conflict on one axis, do you even need to check the second? The answer is no. Exactly, right? And so this is a pretty neat algorithm because you can pretty quickly, usually, determine that, hey, it just ain't going to happen, okay? So the situation, the key is right here, all right? You check one's max against the other's minimum, and there you go. If one box's max is smaller than the other's minimum, there is no collision. And if there's no collision on one axis, there can't be a collision on the others, okay? And so you exit immediately. There's no need to check the other axis. It is super darn fast, okay? And so here's the outer shell, okay, how you can do this. You're going to check the first box's max. Make sure that it's larger than the other's min. If it's not, you break out, okay? And you need to check the other one's min and make sure it's smaller than the other's max, okay? And there you go. You now do the same thing to the other axis, and if you meet all these checks, then you have a collision, okay? And there you go. Not too bad. Not too bad. You could remember this for a final exam, couldn't you? Well, everyone thinks that. And then the final exam arrives and you forget and you reverse the things and now I -1 you for knowing what you should do but forgetting what it is. Anyway, colliders versus triggers. Now, if you've taken 494, you already know what I'm about to talk about. But if you haven't taken 494, as some of you have not, then you might not know what the difference is between a collider versus a trigger, or why there's a distinction at all. Don't they kind of sound like the same thing? Well, I want to show you some gameplay footage. I'm going to play this game for you, and I'm actually going to give you some sound effects, okay, to help you understand what the problem with this game is. There's a big problem with this game. I want to collect these lovely little boxes, okay? Are you ready? Okay, here we go. Ouch, okay. Let's grab the next one. Oh, I got sent into the air. Ouch, okay, this hurts. Oh. Okay, hold on. Oh, you see how I got like, I'm getting, okay? The box goes away, but we are getting hit by the box. There's a physical collision here. Not there. There's a physical collision here that we don't want. This isn't how you collect things in a game. This is how you collect things in a game. Mario's just sprinting through, and you detect that there's a collision, but you don't do any physical ramification, okay? You just run through, and you despawn the object. Mario keeps all of his momentum. There's no physical collision, and it feels incredible, okay? Compare that to this kind of collision, where Mario jumps up and bonks his head very physically on this object. And the object kind of goes up, right? So you get this really good sense of physical collision, okay? No collision, okay? Or you could say these are trigger collisions. This is when we are detecting that a collision occurred, but we are not following through with the physical results, okay? Over here, we do have a normal, like IRL physical collision, okay? These kinds of collisions generally don't exist IRL unless you got some computer vision detection happening with a camera, at which point you can detect a human walked into an area, collided, without feeling any collision, okay? And so in Unity, in other engines, this is usually you taking a collider component and you just kind of toggling it from trigger mode to collider mode, or from collider mode to trigger mode, okay? And that's just how it works. Colliders have that physical collision, but if you do a trigger, you just smoothly, buttery smooth, go through the object and collect it, okay? And it's a very good time. On your homework, you will have to implement both, because every actor can now have a collider and it can now have a trigger. It cannot have multiple, okay? This is not a mature component-based solution yet. It's very hard-coded that an actor can only have one collider and it can only have one trigger, or it can have both, or it can have none. That's it. In homework 7, you will, actually homework 8, in homework 7, you'll introduce the concept of components. So we can add 1 billion components if we want to. Homework 8 will introduce the topic of colliders and rigid bodies and stuff like that, okay? But here, colliders in your homework will specifically relate to things like damage and velocity change. And for triggers, you'll be dealing mostly with dialogue, okay? Triggers will cause dialogue to happen, and there you go, all right? So there are some performance concerns that are really important on this homework 6. We're probably going to finish a bit early, and so we'll do some extra office hours. But on homework 6, you've got a bit of a problem, okay? You're going to hit some test cases that have millions of actors in them, okay? And the performance cost can be immense, all right? I'm going to show you what the staff homework 6 solution performance was on this million actor test case before any optimizations. Do you see this screenshot? This was my desktop computer where I was developing the homework. And you can see what kind of crazy test case we got. They're just characters everywhere, right? And you can see the frame time that I was calculating was 90 plus seconds to calculate one frame. 90 seconds, all right? Ooh, that's going to be, the auto grader is going to take a long time with that, right? That's a big problem.
The 90th FPS question mark?
Yeah, like this is worse than slideshow. In fact, the game is going slower than my slideshow up here, okay? I'm rendering faster than the game is. So 95 seconds, okay? But after introducing what we call a region system, the same exact frames were computed at around half a second. And actually, we got it better. I think you'll see results in here that were we got down to 0.2 seconds. That is dangerously, that's dangerously close to, 0.2, actually, that's crappy. But that is that's approaching double-digit FPS, right? Yeah, right. That is we're almost Bethesda grade. Okay, let's keep going. So test cases with 1 million actors. What are we going to do here? All right, AABB is being used, and we can see that it's AAB is very fast, but it's not fast enough. Okay, do we have any ideas for optimizations? One big optimization you can make that's extremely easy, outrageously easy, you just have to think about it, is do all actor types need to be checked, and against which other actors must they be checked? Okay? Because which actors can even have a collision? Some actors can have a collider, some actors will have a collider, some will have a trigger, some will have both, and some will have none. Yes?
Only the ones that move or even stop people need to be checked. Everybody else is just there. I haven't fully looked at the spec.
Yes, I think you're correct. If you're not moving at all, and you can't move, and you know that, because the config, characters can't decide to start moving halfway through the game, in this game, you're right. You can do optimizations like that. That's good. I wonder if we're doing that.
I wouldn't even consider it myself at first. I was just saying if I actually had you do
yes.
adding the data structure, all those can be expensive.
Yeah, I don't remember if the staff solution does that optimization or not. Yes?
Wait, but couldn't you collide with someone that's not moving?
You still can. But the thing is,
versus each other.
yeah.
You have to iterate through every actor move. You don't have to iterate through the ones that don't.
The thing about optimizations,
They're so
what I love about these optimization questions is you have to kind of sit down and think about it. Okay, if I introduce this optimization, will it break anything? And often on these Test Suite 6 test cases, you're going to think about an optimization, you'll implement it, and then suddenly a test case that was correct but slow is now broken. And you'll realize, it does not account for all cases. So here's something you could do, right? If a actor doesn't have a collider, it can't collide with anything that does, okay? What about triggers versus colliders? Can you kind of separate and treat those differently, okay? You can, all right? When you do these, when you do those kind of performance improvements, you get a lot of time back. And I mean quite a few, a ton. Yes?
I understand we want to trade data memory for speed.
Yeah.
Is there an upper limit to how much memory we should consume in order to bring speeds down?
If you start crashing the autograder, then that's a good sign. Yeah. We had some students who were doing that.
Oh.
Yeah. Just be careful about that.
Yeah. It doesn't have the strict memory limits that Chewy wanted.
Yes, that's right. It does not have. It doesn't have strict memory limits. No. Using more memory can sometimes slow you down. So you do want to be careful, and you want to profile stuff. All right. Here's a huge one. Okay. May you get away with only checking actors that are near you? Okay. And by the way, what does near mean? Think about it this way. If I'm sitting here in the city of Ann Arbor, should I concern myself with accidentally running into and stumbling against and hurting myself and colliding with someone in Chicago? No. Okay, if I know they're in Chicago and I'm in the bounds of Ann Arbor, I just don't care about them at all. All right? So I can ignore them in all of my checks. Let's make that smaller, because that's not excluding many people. I still care about everyone in Ann Arbor. What if I say to you that I'm on the North Campus of the University of Michigan? Do I need to care about colliding with someone on Central Campus? No? What if I'm on the border between Central and North Campus? I still don't? Are you sure?
Now you have to consider it.
Yeah. So this is a little bit tricky, right? But the smaller you can make the region of consideration, the less work you're going to have to do, okay? There's some math that you can do, and you can go to a whiteboard or get out a piece of paper on this. But you can size this. You can decide how big your regions will be based on how big your characters are, your actors are, and you can make guarantees all of a sudden that it's not possible for actors in these regions to possibly hit each other. Okay, even if they're close to the borders of the region, it's not possible. I'll leave that to you, though. So could it change per scene? No. Okay, so there are lots of things that are rigid in our game right now. Actors cannot resize themselves mid-scene. You cannot spawn new actors mid-scene or destroy them, okay? And so you can use these facts to dramatically speed up your collision detection, okay? Notice actors are not allowed to resize or change colliders after the scene is loaded, okay? This is a really interesting point of tension between performance and expressiveness. General game engines like Unity and Unreal, they're not always considered the highest performance, okay? Why? Because Unity has to support any type of game, any genre under the sun. The user could do anything, okay? The developer could want any kind of game. But if you go to Stardock, they have an engine that is designed for very specific genres in mind, okay? Genres that don't need multiplayer, that don't need luxurious collision detection, okay? As a result, they can make certain guarantees about, for instance, the size of their actors, and as a result, they can dramatically make things more efficient in terms of detecting collisions, okay? This is one of those examples. If you cannot guarantee the size of each actor will stay the same, then you can't make some of these collisions that you're gonna do. Okay. Have you ever played RimWorld? Okay. Right. People like RimWorld quite a bit. I think no.
I am only by proxy my brother, but I'm wondering if this is going to go into a realm of, oh yeah, it takes me 10 minutes to load. I can go out, get a drink, come back, and it's still loading. You're
wondering like, what am I going to say about RimWorld?
Yeah.
Okay. Well, you'll have to find out. So I'm going to show you the trailer of RimWorld so you can see what kind of game this is. It is a very tile-based game, as you'll see.
You might think this colony humble. It was no simple undertaking. The three of us crash-landed here. Elena, a princess.
Manual labor is unbecoming.
Greg, librarian, good with books, not much else. And what use is a washed-up soldier like you, Nelson? Now we are survivors. We built, mined, harvested,
endured frightful conditions,
and manhunting rabbits.
Beastly pirates raided us.
We captured some, recruited others.
We lived new lives.
Entertained ourselves. In time, Greg and Elena married.
One must compromise one's standards here.
For company, we tamed turtles. But not everything can be tamed.
Greg started to drink.
You wouldn't stop cheating on me.
Others knew how to treat Lady Greg.
That was when Greg broke down and ran naked into a lake. Yeah, well, let's not forget when Nelson hung out with his llama all day instead of building solar panels. We all need downtime, Greg.
Despite everything, there was progress.
We began work on a ship to set us free. But there will be no escape today. This is my base. This is my sanctuary.
This is my palace.
This is our colony.
Okay. So there's a lot going on in this game, and it is very grid-based, okay? But it is one of those kind of continuous games that have a fake grid, okay? Very, very impressive game, and a lot of people really love it. But during the development process for this game, they actually started running into a lot of performance issues, okay? They had very big constraints on how big they could make their map, for instance. let me pass. What's going on here? Oh, it's being hidden. Okay. Yeah, so tons of units, complex world, and it had pretty good performance. And one of the reasons they were able to do all of this was that they implemented basically a spatial hashing system, a region system, to simplify collisions. And I want to show you part of a developer talk where they talk about this technology a little bit. Okay, very interesting. And I would encourage you to seek these kinds of videos out if you're interested in these topics. Okay.
So, we've got all these problems, and to solve them, I have created what I'm calling the region system. So, fundamentally, the region system is a new set of data structures. When you think about how you think about, how do you as a human being think about space in the real world? You probably, if I ask you, can you reach, from this room to this room in your house, you're not going to think about it in terms of 1 square meter steps on the floor. You're not going to think, okay, I can walk forward 1 step, and then I can walk forward 1 step, and then I can turn left 1 step, and then I can walk through the doorway 1 step, and this long series of operations, and eventually mentally arrive at your destination. Because, yeah, I can get there. You're not going to do that. What you're going to think is, okay, I'm in the bedroom, and I can get to the hallway, and then I can get to the kitchen. And then that's only 3 operations, and they're a lot quicker. What you're really doing there is you're working through a different data structure at a higher level. You're not going step by step. You're going room by room. And so that is really what the game needed. That is what these guys needed, is a new data structure to look through. A new set of information that the algorithms could use. So, once you got your data structured well, the algorithms are usually pretty obvious. So that's that new data structure is these regions right here. And so each region is a small area of the map. It's a set of cells that can each reach every other cell in the region with no restrictions. So there's nothing that could possibly block anybody from traveling within the region. Ditto for here, ditto for here. If you look, you'll see that, say I cut this in half. Now it's 2 separate regions. There's one on the right, and there's one on the left. And there's one on the bottom. When I mouse over these regions with this debug view, it shows you all the other regions that are considered connected to that. So in this case, it's just the ones that are up, down, left, and right. So you get that sort of cross shape. But if you're around a wall, you're only going to see this one. You can only see the region to the left, region to the top, region to the right, because of course you can't walk through this wall. So this region is not adjacent to the other one that's on the other side here. So that's pretty cool. And that means that we have access to some new algorithms. For example, let's see here. If you want to find the closest object, now instead of checking the global list, what we actually do is we just start checking through the regions. Each region keeps a list of the objects that are accessible from within it. And that means that, say we're like, what's the closest grass to me? We're using just the list of things that are in the local region first. So, if Victor is standing anywhere near some grass, he's going to see it because it's going to be in his region. But then if we don't find it there, then we look to the adjacent regions. And if we don't find those, we look to the adjacent regions after that. Now, it sounds similar to just checking every cell, but because the regions are so much bigger, it's a lot more efficient. You're looking through a lot fewer empty spaces. And remember, as soon as you find something, you stop searching. So if you find it in the first region, you're going to never check any of the other regions. You're going to do very, very little work.
Right. So what we basically have here is a data structure where we're trading additional memory, more memory in order to speed up how we can answer questions. Okay. In this case, they have a lot of questions they want to answer related to pathfinding and finding objects and, okay, what is in my region? In our case, we want to find objects too, but we want to find other colliding actors. And so you'll be implementing something very similar to this on homework 6, toward the end of homework 6. A lot of students from the first year we did this really enjoyed that optimization challenge. And I think you'll enjoy it as well. This is a very natural logical upgrade from the homework 3, 4, and 5 spatial map that you almost certainly had. You almost certainly had some sort of map, probably an unordered map data structure, that allowed you to use your X and Y position to look up what is in this cell. Okay, how many blocking actors are there? Are there any? Maybe you used an integer, or maybe you used a bool, okay, that you kept track of somehow. Maybe you used a vector of actors, so you can look up which actors are there for rendering purposes, okay? But it's going to be a pretty natural upgrade of that. So here's what you have in homework 3, 4, and 5, okay? Bunch of grid cells, okay? Now, what you will probably do is you will probably move to a larger system of continuous cells. You'll call them regions, okay? And so you might have a region, right? It's basically a bigger grid that you might find yourself in the middle of a cell, okay? And a region is basically a list of actors that are in that area, okay? So you might have an actor that has a collider like this. And you would say, well, my actor is entirely encompassed within this region, okay? Collider right there. What regions is the goose in? It's in this 0, 0 region, okay? What about now?
It's in all 4 of the regions. 0, 0, 1, 0, 0.
Yeah, so it's actually in multiple regions. So you would probably say, if I want to find possible objects I might be colliding against, possible actors that I might need to check against, AABB style, which are the ones you're going to check against? Are you going to check against any actors in this region? There could be a lot of them, but you're not, right? Okay. One thing you can do really easily to know what regions you're in is you can do a little bit of math, some division, okay, to very quickly in O of 1 time figure out that you've got one vertice in the 0, 0 region, you've got one in the 1, 0, one in the 0, 1, and one in the 1, 1 region. These are your 4 regions that you are in. These are the 4 regions that you care about from a collision perspective, okay? So you can use the cores and vertices and some division to quickly calculate which ones you're in. Okay, now what are you going to do? There are different things you can do here, but I'll tell you what the staff solution does. Which regions are you in? Yeah.
At least 8.
Yeah, you're in 8 regions, okay? Now, how will you figure this out? Will you do some interpolation between your various vertices so you can find which ones? What will your step size be? You can write some math to figure this out. I chose not to. You know what I chose to do? Yes?
Do you just make the regions the size of the largest actor?
Yes. Awesome. Bingo. What regions is the goose in? All those. So here's what I'm going to do instead. I'm going to make my regions big enough so that the largest actor can fit within them. This is sometimes inefficient, right? If you have a lot of tiny actors, but then one huge actor with a collider, you're going to end up with a really huge region system, and all of the characters are going to be colliding against each other and checking each other when they don't need to, right? Edge cases, right? The edge cases are what a general purpose engine would really care about, right? Like Unity. Unity would care about that kind of thing, but we might not, okay? So our region size can be chosen to make calculations easy and to make them very fast based on the size of our largest actor. That's one thing you can do. Now, there are ways to go even faster if you don't do this little hack that I'm doing and resize the regions. But, this is one way you could go, okay? Questions? Yes?
Is there like an optimal region size, like based on actor?
Biggest actor size?
Like what's like the optimal?
Well, something to think about. So picture this. We have a region system, and in general, an actor will only check against other actors that are in the same regions as it is. Okay, if it's on the corner, right? What's that? The kitty corner, it's called, right here. It's you might have to check up to 4 regions. Okay. Imagine what would happen if we said our region is going to be really big, like. Our region cells are the size of the entire map.
have regions.
Yeah, what is the purpose of having regions? The purpose of having regions is so that you can say, I'm in this region, I don't have to care about ones that are far away, right? But if the entire map is within the same region cell, that's worthless, right? The smaller you make the regions, the fewer comparisons we need to do. The less likely it will be that every actor is in that region. No, chances are there will only be one or maybe two other actors or maybe none in your region, and so you don't have to check against anything or just very few things, right? And so that becomes pretty nice. Your O of 2 and N2 algorithm, where you have each actor checking every other actor, starts to look more like a linear time check, right? Where you just look at every actor and is there anything nearby? Nope, you're good, okay? So here's a little demo here, okay? We have a bunch of actors now. Which actors should you perform an AABB check on? Are there any actors you see that might be in contention? Yes?
The duck and the rat.
The duck and the rat, and why?
Because they're in the same region.
Bingo, they're in the same region. What about Villy over here? Does she have to care about any other collisions? Right? No, not really. The bunny doesn't. Okay. It's all good. Okay. And so, one thing you might do as well is you might check your current regions and your neighbors. Depending on how you want to implement this, you might say, if my main region is this one, I might check my neighboring regions, but I'm not going to check any more. If you check via vertices, you might say, I probably don't have to check the neighbors, right? Because I know I'm not in there. Actually, you know what? You might not be, one of your actors might not be in other regions, but you could have another actor that's in a neighboring region that is hanging over and into yours. So depending on how you structure this region system, you might have to do certain checks or you might not, okay? I think most students kind of do it a slightly different way, but as long as you're getting accurate, correct results, you should be fine. So the goose here is going to check 2 other actors instead of 5, okay? It might check the rat and the squirrel, okay? Imagine checking only 2 instead of the other 1 million actors. And you can see why this is such a big boon for performance, okay? Why you could go from 95 seconds for a frame down to half a second, down to 1/5 of a second, okay? That is a huge deal. The smaller the region size, the better, all right? But if you go too small, then you could get bugs where the region system says you don't have to check this other actor, but actually the other actor, you should have checked it and it's colliding with you, and boop, now you've got a correctness issue and the character is not where they should be, right? That's a thing that can happen, okay? How small can a region be without causing bugs? Okay, that's something to think about. Performance improvement substantial. So before, right, 95 seconds, and then after, right, we get down to 0.63 or so. Okay, and then the other optimizations knock us down even further, down to like 0.2 per second. Okay, so very, very, very big, like 99% time save. And if you want all those points, if you want to be the first student ever to complete Homework 6 100%, then you might have to do some of this stuff, okay? Because no one last year got 100%. I think we had someone who missed like 1 test case and that was it. Very salty, okay? But the prize is still up for grabs. The history books still have a blank page waiting for your name, okay? So think about it. All right, and have fun. I really, really like these optimization challenges. Not that I'm any good at them, but it's the kind of thing that you can really spend a lot of time thinking about, and you come up with these eureka moments. Oh, what if I tried this, and maybe it works, and maybe it doesn't. All right, but remember what it means to do continuous testing, test-driven development. Okay, you can submit a slow version of your engine. Okay. A slow version of your engine, and then you can work on optimizing it. The autograder is a continuous testing device. It will tell you whether you broke something with your optimization, okay? So get as much correctness as you can, and then use the autograder to keep yourself correct while you do these dangerous and sometimes risky optimizations, okay? And that'll tell you whether you kept things correct. Okay, question?
What if you have okay, this is homework 4. What if you have an optimization that works on one OS but completely breaks on another OS?
Well, that sounds like a bit of a problem. That doesn't sound like 100% to me.
That's some undefined behavior you got there.
Yeah,
I
sounds
have
like
an
it.
issue with that.
Because apparently Linux is not like auto for some reason. So that's cool.
No, I almost never use auto. You know why? Because I see auto and I just get myself confused about what my data type is. I write the little dash and the caret, the little arrow for the pointer, and I get really confused when a bunch of weird function shows up. I'm like, wait, this isn't what I thought it was. Anyway, sometimes the data type signatures get so long that it takes up basically the entire width of your monitor just to put the data type there. Yeah, that's when the auto is basically not an option anymore. Let the compiler figure out what type this is. Okay, any other questions, comments? Okay, about 10 minutes early, not too bad. So we're going to begin office hours. Please start with your homework 6 as soon as you can. And please let me know if you have any questions. I don't think it's going to be the worst thing in the world for you. And remember this, you don't have to complete those super hard performance test cases to get a pretty good grade on this homework. So if you're out of time or you just want a break, that is something to think about, okay? Not the end of the world if you make that choice, okay? Good luck to all of you. Please have an excellent weekend. Rest up a little bit, but do get some homework 6 in there. And I'll see you on Monday, okay? See you then. Okay, everyone on Twitch and YouTube, I'll see you later, okay? Have a good one. Bye-bye.